Okay, let's finish this 1993 AP Calc BC multiple choice. We left off on 37. This says if f of x is x for x is less than or equal to 1 over x for x is greater than 1, then the integral from 0 to e of f of x dx is, well, we had to split this integral up because it's piecewise over here, okay? So e is 2 point something, right? 2.7 if I remember correctly, around there. So we have to split it up at the not discontinuity. Is it discontinuous actually? It's not discontinuous, but at this point where it switches the function, okay? So we integrate first from 0 to 1 of this guy, because we're on this curve, okay? X dx. And then we integrate from 1 to e of remainder, because that's in this interval now, okay? So what is this? This is just, this we don't even need to do the parallel, but we could. We know that it's the area of the triangle, because this is just a straight line, right? But let's just do the parallel. X squared over 2, evaluate from 0 to 1, plus this is log of x, evaluate from 1 to e, okay? So this guy would just be half. This guy would just be plus ln e. Ln e is just 1. So it's 1 plus half, which is 3 halves. And we move on. During a certain epidemic, number of people that are infected at any time increases at a rate proportional to the number of people that are infected at that time. This should signal exponential growth. If 1,000 people are infected when the epidemic is first discovered, and 1,200 people are infected 7 days later, how many people are infected 12 days after the epidemic is first discovered, okay? So remember the general equation for exponential growth decay? If you remember the compound interest one, PERT, it's the same thing. As y is c e to kt, where c is the initial value. So we know the initial value is 1,000, okay? So at t is 7, the value is 1,200. So 1,200 times initial value 1,000, e to the k times 7, because t is 7, and the value is 1,200, okay? We solve for k, the growth constant, so 1,200 divided by 1,000 is e to the 7th k. We log both sides, it's ln of 6 over 5 is 7k, or k is ln of 6 over 5 divided by 7, okay? So I kept it in exact form for now. So we want y when t is 12, so we just plug in now. Y is 1,000, that's the initial value once again. E to the k, we found k. T, we want it to be 12. Plug it into your calculator, you get 1367. dy dx 1 over x. Then the average rate of change of y with respect to x on the closed interval 1 to 4 is, this is just asking what the average value is, okay? This is the rate of change, 1 over x. So the average value of the rate of change is, where did I write it? Over here. So it's from 1 to 4, so 1 over 4 minus 1, integral from 1 to 4, 1 over x dx, okay? Once again, they're asking, they give that dy dx, well, we know dy dx is a rate of change, okay? So they want the average rate of change from, in this interval, so that's the average value of this guy from 1 to 4. So that is what I did right over here, 1 over 4 minus 1, integral from 1 to 4, 1 over x dx. This is just log, so 1/3 ln 4 minus ln 1. ln 1 is just 0. So it's ln 4 divided by 3. But we don't get one of those answers here. So we gotta do some math, okay? It looks like maybe we had to make it in terms of ln 2. So that's what the hints I used. We know that ln 4 is ln of 2 squared. 2 squared is 4. Properties of logs, we can bring this power out in front. So 2/3 ln 2. Okay, Simpson's rule, here we go. Let R be the region in the first quadrant Enclosed by the x-axis and the graph of y is ln of 1 plus 2x minus x squared. If Simpson's rule with two subintervals, oh, okay, good, only two subintervals, so that's not too bad, is used to approximate the area of R, the approximation is, remember what Simpson's rule says? It's just delta x over 3, and then there's that 1 for 1 coefficient thing, right? So hopefully that sounds familiar. So to approximate it, let's first find delta x. We want two subintervals, so delta x is, well, they tell us it's from, oh, they don't tell us from 0 to 2. So how did I know that's from 0 to 2? Well, they tell us it's in the first quadrant. So we probably want to find when the zeros of the sky, okay? So this function is 0 when the arguments of the log is 1, because ln of 1 is 0, okay? So I set 1 equal to the inside of the log. So 1 is equal to 1 plus 2x minus x squared. So that's where this line comes from. Okay, so we solve for x. We just move this 1 to this side. So 0 is 2x minus x squared, which we can factor out x. So it's x times 2 minus x. So we know that the zeros are at x is 0 and x is 2. So that's how I got my limits of integration, okay, from 0 to 2. So we were trying to approximate integral from 0 to 2, y, which is this guy dx, okay? So delta x is b minus a over n, which is 1, okay? So this is the formula for Simpson's method, okay, if you remember this. So delta x is 1, so 1/3 times what's y of 0, so plug in 0. That's ln of 1, which is 0. What's y of 1? We plug in 1. So that's 1 plus 2, that's 3 minus 1, that's 2. So ln of 2. So 4 times ln 2, that 4 comes from Simpson's rule. Y of 2, we plug in x is 2. So 1 plus 4, which is 5, minus 4, which is 1. So ln 1 again is 0. Okay, so we're just left with 4 ln 2 divided by 3 as our approximation. And you plug that into your calculator, and that is C. So I don't know if they teach this anymore, Simpson's rule, but that's how you do this one. Okay, next we have f is the sky. At what value of x is f a minimum? When it talks about max min, what do? We differentiate. How do we find f prime? This is very easy. Fundamental theorem of calculus. So, is this the paper? I think this is, okay. So, let me also check that I did it correctly with the key. Yes, okay. So let me now show it. Okay, so we want to find f prime from here. How do we do that? Fundamental theorem calculus. We just plug in the upper bound as t, wherever there's a t in the integral. Okay, so that's what I did here. But we need a chain rule, so we need to differentiate this guy also. That's just 2x minus 3. Okay, we set it equal to 0. So the finding derivative, that's the easy part. We set it equal to 0. Okay, and then we do the first derivative test. So we find the critical points. There's only one because e is never 0, so this can never make this product 0. So only this guy will make this product 0, and that's when x is 3 over 2. So let's double check that it's actually min. So I'm doing the first derivative test. We plug in some number less than 3 halves, for example, 1. Remember we just said e is always positive, it's greater than 0. So when we plug in 1, here it would be negative. Plug in some huge positive number, this would be positive. So we confirm that it's a min because the derivative changes from negative to positive. Okay, so 3 halves. All right, this one, this limit, we have some function of x to some function of x power. So you got to be careful. This is logarithm. You have to use the log, that technique. Okay, so where did I work this out? Give me 1 second to find it. Well, I guess it's on this page. Okay, so we define y to be what's inside the limit. When you log both sides, it'll be ln of this whole guy. Okay, properties of logs, we can move the power out in front. So cosecant x times log of 1 plus 2x. Okay, that's ln y. We can even rewrite this as log of 1 plus 2x divided by sine x. Okay, I changed this cosecant to 1 over sine. So now when we find the limit as x goes to 0 of ln y, which is this guy, we have, when x is 0, we plug it in, we get 0 over 0. So we can use L'Hopital's rule. Okay, we differentiate the top, that's 1 over 1 plus 2x times 2 by the chain rule. We differentiate the bottom, that's just cosine x. Okay, now we plug in x is 0. What happens? Well, the bottom is just 1. The top, we get what? There's a 2 there, and there's a 1 there, so it becomes 2 over 1, which is 1. 2. Okay? We're not done yet, because we found the limit of log y. To find the limit of y, we just exponentiate this, and so e squared. Okay? So before I pick this one, we weren't finished yet. You have to exponentiate. Okay? Last few problems. Coefficient of x to the 6 in the Taylor series expansion about x is 0 for f of x is sine of x squared is. So the quick way to do this is, well, you should know what the Taylor series of sine is. That's x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, so on and so forth. So sine of x squared, wherever there's an x, you plug in x squared. So it becomes x squared minus x squared to the 3rd power over 3 factorial plus x squared to the 5th power over 5 factorial plus so on and so forth. They're asking about the coefficient in front of the x to the 6th term. That's this guy, x squared cubed is x to the 6th. Okay, so what's the coefficient out in front? It's minus 1 over 3 times 2, which is a. Okay? All right. If f is continuous on an interval a to b, then there exists c such that c is between a and b, and integral from a to b, f of x dx is what? Okay? So this sounds like mean value theorem. And what does that say? All right. You can either use the mean value theorem from that you learned from the derivative top sections, or you should also have learned that there's also a mean value theorem or the average value theorem, or whatever you want to call it, for integrals. They're exactly the same thing though, okay? So you can use either. So let's use the one for integrals, okay? So what does that one say? Well, once again, they say the same thing. But remember how we find average value? That's this side over here. 1 over b minus a, integral from a to b, f of x dx. That's the average value of f on an interval from a to b, okay? The theorem says that there is some c, where c is between a and b, such that f of c, I wrote it over there already, f of c is the average value. That's what the theorem says, okay? So we just want to get this guy over here. So we just multiply by b minus a on both sides. So b minus a times f of c. So 44 is E, as simple as that. Okay? Why are these choices there? They're to confuse you because this guy, so I wrote this side, the average value is 1 over b minus a times, if capital F is the antiderivative of lowercase f, it's capital F of b minus capital F of a. Okay? It's not lowercase f of b minus lowercase f of a, so it won't be this guy. So these are all trying to trick you that when you integrate f, it's capital F actually. It's not lowercase f still. And it's definitely not f prime, so you got to be careful about that, okay? So it's as simple as E. All right, last one. If f is the summation as k goes from 1 to infinity, sine squared x to the k, then f of 1 is equal to what? How do we solve this? Well, we need a calculator for this, but you should recognize that it will just be summation k goes from 1 to infinity, sine squared of 1 to the k. We can even plug this into the calculator. What is sine squared of 1? I did not do this beforehand. That's what I'm doing live, but let me pull up my calculator. Give me 1 second. Okay. Let me do it in, let me make sure I'm in radian mode even. You were allowed a scientific calculator in this exam. Okay, so we want it as sine of 1, but that whole thing squared. Okay, it's around like 0.708073 dots. Keeps going. Okay, to the k. Okay, this you should recognize as the geometric series. Okay, so we know what the sum of the infinite geometric series is. It's the first term, which is sine squared of 1. Okay, so I'm going to write it in exact form for now. Over 1 minus the common ratio, which is sine squared of 1 again. Okay, so first term, 1k is 1. That's just sine squared 1 to the first power, which is sine squared 1. And the common ratio is again sine squared 1. So let me plug this into a calculator. Divide by 1 minus this guy. Okay, so I got 2.425519. Okay, that is which choice? 2.426. That's G. Okay, that's how we do this one. You just have to recognize that, well, when we plug in x as 1, that's just some constant value. It's a irrational number, it looks like, but it's still a constant value. Okay, this guy is just a geometric series, so we know that the sum of, by the way, we know that it's a convergent infinite geometric series because the common ratio is less than 1, absolute value of the common ratio is less than 1, so we can use this guy, the first term over 1 minus common ratio, that's the sum, and that's how we got this. Okay, hope that this was helpful. Please like this video if you found it to be helpful. Please subscribe to the channel to look out for the next video.